Hello everyone. As promised, here is the next example of me solving a system of equations by elimination. So here I'm going to have two equations, two linear equations, because that's what we're studying. The first one, 3x minus 5y equals 6. The second one, 7x plus 5y equals 14. And we want to solve, the instructions are solve this system of equations. We could try and solve it by substitution, but we're learning this new method called elimination. And the principle of elimination is to take one of these equations, 3x minus 5y equals 6, for example. I'll draw my golden road. And the idea here is essentially to add the next equation to that. So right underneath, I'll add, on the left-hand side, I'll add 7x plus 5y. And on the right-hand side, I'll add 14. The idea being that the left-hand side and the right-hand side are equal, so we're really adding equal things to both sides, doing the same operation to both sides. Okay. When I add those two equations together, I'm really lucky, because I get 3x plus 7x here for 10x. And the whole point here is that negative 5y and positive 5y add together to make 0. And then on the right-hand side, I get 6 plus 14 is 20. So now I've turned my two variable equations into one single variable equation, which I can solve swiftly like this. X equals 2. Now that I know that x equals 2, I can go back to one of my equations, like 3x minus 5y equals 6, and I can say, okay, by elimination, I found out that in order to solve both of these equations at the same time, x has to equal 2. Therefore, I'll turn x into 2 in one of these equations, so I'll substitute the value 2 in for the variable x in one of my equations. And when I do that, I again take a two-variable equation and turn it into a one-variable equation, which I can then solve. 6 minus 5y equals 6. If I draw my golden road and solve for y, I'll subtract 6 from both sides. Negative 5y is equal to 0, and dividing both sides by negative 5, I get y is equal to 0. And so my solution to the system of equations above is this ordered pair to 0. It's usually pretty important to me to understand what I've just accomplished when I think I've finished a problem. And so in this case, I'll take both equations that I started with, 3x minus 5 equals 6, on the one hand, and 7x plus 5y equals 14 on the other. And what I just accomplished was that I found an ordered pair that can solve both equations at the same time. And so I'll test that out. I'll replace the variable x with the number 2, and I'll substitute 0 in for y, in which case I get 3 times 2 is 6, minus 0 equals 6, and that's true. So 2, 0 does solve the top equation. Now I'll check the bottom equation here. 7x plus 5y equals 14. Substitute the ordered pair 2, 0 into that equation, and you get 7 times 2 is 14 plus 5 times 0 is 0 equals 14. Also true. Equation solved. Or system of equations solved. Next, I will do a pretty special second example for the day.